Alright, let's continue. I think if I remember correctly, I think we need to add this function. Use parameter. Hello, welcome Richie. I'm still coughing for a bit. So yeah, other than that, I'm fine, I guess. Oh, you joined my Discord server. Okay, welcome. I rarely take a look at Discord, but I will check it out later on, I guess. Okay, I'm continuing this book on chapter 11, which, as far as I understand, trying to create a variable it is storing the value in some kind of environment, and now we are trying to create, where is it? Trying to create this function, the arithmetic one, so that we can put it in the environment that we created, something like that. We create new environment, and then we initialize the built-in function into the environment. Maybe something like that. We will see. Hello. Black mode joking. Welcome. Yeah, I'm currently trying to build an environment to store the variable for our simple Lisp interpreter. And yeah, I'm currently trying to create this function so we can add that in the environment that we just create. Like this, we create new environment, and then we initialize the built-in function such as list, head, and so on. So let me create this first. Wait, but before that, is the unused attribute. Let me try, what is it called? Let me try to suppress this warning. Use the unused attribute. Nice. Let me try. Unuse something like this. This is one parameter. Yeah, I mean, ideally, we don't have the unused parameter. Oh, no, unused parameter. Okay, let's try this. Okay. I mean, yeah, we need this parameter so that you can save that in our environment. Alpha built-in add. Okay. Okay, so I mean, still use this. So we return that. Okay, we return that directly. Right. C is a good language. It is my favorite one. Okay. Well, it is quite interesting, I guess. What keyboard are you using? I'm currently using keyboard called Cendrawasih keyboard. Let me Cendrawasih keyboard, something like this. It's basically an Ali style keyboard, I guess. Yeah, something like this. is a Ergo keyboard. Button use AI to generate error code. Your C code. It depends on what you mean AI. If it is actual Indonesian, then I am the AI. Okay. Pin my Discord in the site. Oh, okay. Let me. I resend. Let me copy the Discord. And I guess. YouTube thing. I mean, in case anyone wants to join the Discord. More people need to eschew the false score of AI. Okay. Yeah, well, the artificial intelligence can be misleading. Yeah, I don't really use artificial intelligence. I like to do it manually, like this. Even though it is, what is it called? Even though it is slow. But yeah, I quite enjoying the process. Value. But in add. Okay. Personally, I don't really like this approach. But well, I am still not sure. What is it called? Another mechanism, I guess. So yeah, for now let's just use this. This is okay, char pointer. And because we are using string literal, we are basically having the, what is it called, the pointer or memory address to pass into this. So yeah, it should be fine. Okay. Yeah, my only concern if we add, what is it called? If we add the arithmetic operation, we need to create another function, right? This make me want to make the built-in type def this one to have what is it called, variatic parameter, I guess. Maybe we can treat that. But yes, C programming optional parameter. The only thing I knew creating the optional argument or parameter is using the variatic function. Okay, let me check. Alright. You will illustrate by writing out on the bare outline of the function. Okay, let's try that out in here. Okay, so instead of only integer and integer, let's add the variatic parameter, and also in here okay. Alright, now let's try compiling this. Okay, we can do that. Now how to validate if there is a variatic parameter? VN list. Okay, for variatic argument list, VN start, variatic argument start, and is there any there's a manual page. Okay. Oh yeah, in case anyone curious, you can do man like this to check what is the main command is. It is basically an interface to check, what is it called? To check the manual of some of the program. So you can do that. If the program has the manual, right? If they don't have that, then yeah, we can really check that out. So you can use main git to check the manual for git or git commit, something like that. And we can also check how many manual we have with the -f flag like this. Okay, this is the, I think the library one, the library manual, and this is the POSIX manual, or the POSIX is the standard. I think let's put that way. The POSIX programmer manual. It is standard for portability, I guess. So if you want to make your program more portable, so you can, what is it called? Running the program in another POSIX compliant system, then you might want to stick with the POSIX standard syntax or something like that. Okay. Void VA start. last? What is last? KVE list. Macro initialize AP for subsequent by KVE arc and VAN and must be called first. Argument last is the name of the last argument. Is the name of the last argument before the variable argument list. That is the last argument of which the calling function knows the type. Which the calling function knows the type. Argument may be used in. It should not be declared as a register value or as a function or an array type. Yeah, I mean, if we use the variatic parameter or argument, how do we execute the function? We have this one, right? And so far, let me put mark here. And so far, we have called the function in here with the environment and value as an argument. Yeah, I mean, if we use variatic function, we might need to change this. Like, when do we execute the arithmetic operation? Something like that. Okay, I think let's just try the simple way or the easiest way, I guess, which is just duplicate this until I find out, until I have another, what is it called? Another inspiration to handle this. Okay. Div, then mod, the mod tool is this. Okay, and then pow. The power. Where is it? Okay. function might be one of. Should we put after the parameter? Oh, this is only GCC extension. It's supported by some other compiler. This isn't as portable. Some other option. It's something proprietary, exclusive. Let's call it that. Exclusive to GCC. You can use GCC or unuse attribute. I use this macro in the header document. Okay. And use, and then what is it called? We concat this, putting this together, and then attach attribute there at the end of the parameter. You try to use bar in the code anywhere. Oh, you try to use bar, so you can leave the attribute in by mistake. And for function, okay. And SVC doesn't have equivalent to this one. For argument which contains parentheses, okay. You can do none of the attributes are supported by key. Under prefix term are reserved for the compiler, so I'd rather avoid this. Make GCC admins putting the attribute seems to work right for funcs, var and parameter. Okay. Calculate for funcs, var and parameter. So something like the find can be used for R3 before the identifier. Yeah, it can be bad if we want only a few parameters, not the whole file. Okay, maybe I will use this. And putting it after I get warning. Let me try that. Okay. Alright. Well, maybe I should use this. Something like this. And then we're trying out this macro. Alright. Attribute unused. Okay. Or maybe, okay. Wait, define unused. Param, maybe something like this. Unused. And then we concat that. Params. Attribute. Wait a minute. Do we need to use underscore? Unused. A lot of people read that without the underscore. Interesting. Before the identifier. And let's try this. Unused. And check the pre-processing stuff. Alright, in case you are new, CPP in here is not C++, but the C processor, which I usually check if I have any macro, something like that. Okay, so this is the result. Unused underscore C, and then attribute, then attribute unused. Let me try compiling that. Okay. Right, I forgot to add in here. Maybe something like this. Okay. Alright. How can I forget about that? Expected 3 and have 2. Okay. Alright. Wait a minute. Do we use unused W extra? Okay. Let's try that. No. Pedantic, maybe. No. Okay. Oh. Okay. So is this in all and extra maybe? Okay. We add, what is it called? Supposedly auto warning, but it's not really auto warning. But yeah, it's supposed to be the common warning, I guess. Where is it? Okay, I cannot find that anyway. Oh, unused parameter. If we do this, unused, okay. Interesting. Alright. Maybe I will use that instead of adding this. What is it called? Unused parameter, I guess. No unused parameter. Okay. Oh, right. I'm also curious. Can you like do this? I mean, a lot of people write it like this without the underscore. Let us try. Okay. It looks the same. Interesting. Function attribute. Oh, okay. It looks like we don't need the underscore one. We don't need the underscore before or after. the keyword. This attribute attached to a function means that the function is meant to be possibly unused. We will not produce a warning for this function. Okay. And use attribute. Okay. Where is it? Now let me copy this in the chat. You know Hindi? No, I don't. American time is 3:30 a.m. Oh, okay. Well, in my time it is 5 a.m. I guess. But anyway, welcome, Vivek. We are currently checking out this, what is it called? How to prevent a warning if we have unused parameter in the function, you know. For example, if we have this, right, we have a parameter called C, but we didn't use it in the function body. And when we compile this, GCC will throw a warning, right? Unused parameter. So we are trying to solve the problem, solve the warning, I guess. And I think we will use this macro. Okay, let me implement it first. We have to find quite a few macro to find what is it? Is it only for the parameter, or we can also use this for the, what is it called? For the variable. Let us try this. In unused, maybe let's try compiling this. Oh, again. Okay, we can also use this for the variable too. What about the function? Oh, if we put the attribute unused at the end, it will become invalid syntax. Now let me demo that, I guess. And write something like this, and then we take a look at the pre-processing result. See, it become like this, which I don't think a valid syntax. Well, we can check that out. Let me copy this. Let's clear that up. Okay, and then let's copy this. Okay, right. Yeah, it's not. I don't think that is a valid syntax. But if we use this, oh, there is China C. Okay. Unuse. Okay. Let me try implement this. To find unuse. Found, and let's call it name, I guess. Use this, and then unuse name. Unuse found. Let's check at the zip processing result in the pager. Okay. Okay, so we have this attribute unused, right? And then this one as the, what is it? As the function name, I guess. Okay, undefined. Reference to it. Where is it? Right, this one. Something like this. Okay, there's an error. Expected expression before attribute. Okay. So we cannot put the attribute in front of the, what is it called? The function name. I mean, at least in GCC version 15.2.1. Okay, so well, at least we know that we can use this, what is it called, macro, right, for the variable too. Okay, unuse name, let's call it that, and then unuse concatenate. Basically we combine this, or maybe underscore, right? So we combine this keyword with the macro argument, so it become one word instead. Okay, and then attribute unuse. Okay, let me copy this as the reference, giving the credit, and then this one, the online documentation. Okay, so let me run again. There's an error, conflicting type. Wait, what? Hold on a minute. Wait. Built-in add. Why is it conflicting? Wait, hold on a minute. Okay. Wait, not that one. I think this one. Interesting. You at top level. Yeah, why is it LENV that is interesting. Think 41. Oh, okay. Yeah, my bad. Wait, my value. Why is it becoming value? Alpha. Okay. Right. Put in sub. Okay, so why did it should be wait, let me count that. One, two, three, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Yep, there's a lot of these unused. $372. Wait. Okay. I solve this one by one. Unused. Okay. Maybe I should create a macro. Unused. Okay. 123. Okay, and then 472. Okay, 540. Alright, 609. Okay, passing argument two of discard const qualifier. Okay. For the array struct, what do you mean? We may take. Yeah, I don't really understand. Okay. Const specifier, right? This is because it is const char pointer built-in operator. Okay, and I will try to address this later on. Let's focus on this one. Oh, my stomach's growling. Okay. 682. Hold on a minute. Okay. Let's use this. Okay. Mod. Okay. Let's. Oh. Right. Where is it? We need to use double parenthesis. Okay. Scan. Right. This make me wonder. Where is it? Built-in. Okay. Oh. Okay. Yeah, we directly use the same, which as far as I remember using the char pointer instead of const char. I mean, maybe we can change that in here. NOP. Let's see how it goes. Okay. So we don't really use this. Other than in the arithmetic operator, right? If that is the case, if we are only using this as arithmetic operator, Maybe we can change the function name other than put in OP. Maybe we can change the name to read. Something like this. Maybe. And then let's put this in multiple line. Built in a read. Okay. And if we expect the operator to only have one character. Maybe we can specify that in the function. Okay, in the function parameter. Void printer const char pointer to, let's say, str, or maybe we can use this one. This means that what is it called? We need a parameter. We need this means that the pointer to the array of one element. Maybe that's how to explain this. And let's try that out. Void printer const char 1 and then printf char. Alright, I forgot to give it the function parameter, the parameter name. Str, maybe something like this. Or let's call it C. And then we use it in here. Printer A. Maybe something like this. Wait a minute. Okay. Oh, right. Because string literal also have this, what is it called? The null terminator. So it's basically A with the null terminator. So it has 2 characters instead of 1. If that's the case, I might as well using the single quote, I guess. Maybe something like this. I'm not sure if we can use cons. Let's try out. Oh, we can. Okay. Alright. Now let's try this. Okay. Alright. I mean, yes, do we really need cons? I don't think so. But yeah, let's try with cons first. Okay. Non-number, okay. Compare this. Okay. Alright. We change the double quote to single quote. Let's get a macro. Okay. Alright, let's try compiling that. Conflicting type. Previous declaration. Oh, I haven't saved the file. Alright. Okay. At least it compiled. But yeah, I'm not sure if we need cons. I mean, we know that const make the variable constant, which means that we cannot really change the value. But yeah, I don't think we need that. Okay. Wait a minute. Right, we are in this one. Initialize the built-in. Built-ins init. Let me put this in the left. Okay, unsign in. So that means if I'm gonna use it in the add built-in, which is this one, I need another array for the built-in function. Maybe I should call this name, fun name. Something like this maybe. Fun names length. And then we need to use this built-in type def, right? And call it, what should we call this? Fun? That's kind of weird, but yeah, maybe that's okay. 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 And then head tail. Built-in head. Then this one tail. Wait. Tail. And then list. And then eval. And then join. Okay. and then the inconsistency of theme. And multiply first. Okay. Adds up. Adds up. Multiply. Division. Modulo and then power. Add. Subtraction. Multiply. Div. Mod. Then power. Okay. Or maybe I should call this from pointer. Maybe okay, from name. Alright. Pointers length. Okay. Not built in but from names. From pointers. Okay. I mean, if the length is not the same as pointer's length, function pointer's length, let's print out what is the error message here. Initialize built-in field. Built-in function field. Function name. Let's just call it this. Function name and function pointers length did not match. I mean, I expect this to be the same, having the same length. So if it is not the same length, print the error message and maybe exit. What exit code should we use? One maybe. And declare first. Right. What is it again? From name string. Because we already checked if it is the same length or not. Let's just pick one. You can also use the func pointers. Discard const qualifier. Discard const qualifier. Jar name. Okay. I'm not sure if we are gonna use this in another part. No, not that one. Add built-in. Okay. Okay. So far we are using the string literal, which have a constant type for the char at least, not the memory address or pointer. Okay. You know what? Maybe we should use const char pointer name to resolve this warning. Okay, conflicting type. Where is it? Expected char pointer. What? Put discard const. Is of type const char. I think, yeah, maybe we should not use const because there's a possibility that we will add the symbol during runtime. it might not be cons. That makes me wonder, what is Lisp? Okay, Lisp is basically a programming language. This one, Lisp is a programming language, so we are trying to create an interpreter for Lisp programming language. If you ever use Python, what we are creating is, well, similar to Python, I guess, but it is way simpler than Python. And well, let me just test this. Okay, and then I'll compile that again, and this is what we have created so far. This is the Lisp programming language syntax. So we are kind of creating a simple Lisp interpreter. That's basically it. Okay. This got cons qualifier. And put in now. Okay. Then in this one, put in. This got cons. Or maybe I should use this, and then we are casting that to char pointer. Okay. What is the difference between an interpreter and a compiler? As far as I understand, well, let's take a look. Compiler versus interpreter. The compiler, what is it called? The compiler translates to the machine code, I guess, to the binary, maybe something like that. And then we can run this binary as a standalone program. Well, the interpreter, well, let me copy this in the chat. Compiler is a translator that takes input high-level language and produce an output machine or assembly language, machine or assembly language is to transform code written in the programming language into machine code, the binary one, the binary format 0 and 1, so that the computer can understand. Okay. What is an interpreter? into a comprehensible language to an intermediate language. It contains pre-compiled code, source code, etc. Only one statement of a program at a time. Interpreters, more often than not, are smaller than compilers. So as far as I understand, the compiler translates into the machine language or the binary format, and then we can run those binary file as is, standalone one, while interpreter convert from the programming language to intermediate language. So in our case, right, well, let me git test first and then run again. In our case, the Lisp interpreter here, right, we are translating from the Lisp syntax into the C programming language because we are using C as the interpreter language, and then C will translate that into the machine code, I guess, maybe something like that. I mean, I'm also still learning, so I might be wrong, but that is as far as I understand. So the compiler translates directly to the machine language, but interpreter translates the programming language that we use into the intermediate language. So in our case, maybe something like this. Lisp syntax into the C, what is it called? C language, I guess. C program. And then to the machine. Maybe something like this. C programming language and then to the machine. Maybe. Yeah, I'm still learning. And there's also virtual machine. It is different again. I mean, I found a blog post called, what is it? Pattern behind the scene. I haven't read this. I think this one. I haven't read this blog post yet, but I will put this in the chat in case anyone curious. This is how, what is it called? The Python command works. But yeah, I haven't read this. I just took a glance and this blog post looks interesting. So yeah, that is the gist of it. At least for now. I mean, I'm not sure if my explanation is correct or not. Because understanding the, what is it called? The mechanism in the compiler itself need some kind of knowledge, I guess. So yeah, I don't have enough experience to explain that. Okay. Right. In case you're curious what GSTP is, is basically this command. I just use an alias instead of typing this command. So when I type this or running this command, it's like I'm running this command, the alias to another command. Okay, yeah. If we're using const char, the put here will throw a warning, because if I put env put, using this one, and well, the symbol that we might save, or the variable that we might save during the runtime, might not be constant. Let's see. Malloc with constant type. Okay, initialize const. Is this the one? And this is the compiler error. Assignment of read-only member. Malloc with const char. Let's see. Using malloc. Okay. Constant string. Casting to memory to a constant string or a constant char. I will be able to get the exact number. Okay. One program into different programming language at once. By definition, one. Size of char. Consider one byte equal one char or one octet. It is 8 bit. There are machines which char bit will be 16 bit. In this case, one byte or one char equal to octet. There may be more than 8 bit, right? And more than one octet. Or more than one octet. But it's always one byte. And it's important to know, especially when developing for cross-platform embedded stuff. second one is horribly wrong. She is set to point to a constant string. You are assigning variable C twice. So obviously the first assignment has no meaning. Variable C twice. It's like writing. Okay. Right. So we in this context we are basically have the value for malloc, and then we are replacing the value from malloc with the value from the string literal, which is a pointer to const char. You're assigning variable C twice, right? You lose the address of allocated memory, so you're not able to release it later. Okay. Let me try that out. Okay. Where is it? Maybe in this one. Const char ptr malloc how many character do we want? Let's just use 3, right? Because we are using char, so if we do, well, we can also do this char, but because char is always 1 byte, so it's like, what is it called? It's like writing like this: 1 multiply to 3. So that's why I just used 3 in here. But yeah, you can also use, what is it? You can also use like this if you want to. I mean, says off will be evaluated during compile time, so it's not gonna slow down the runtime or when we run the program. And then I'm not sure if this is gonna work. Const char str ap. This is because, don't forget, we have the null terminator, right? 1, 2, and then the third character is the null terminator, the \0. Okay, and then wait, I think I need to use this. So I use string. Well, let's find out. We copy the string. Wait, strcpy. Okay, looks like we need string header file, destination and source. Okay, so the destination is ptr, and the source is str, and then we can print it. What is it called? ptr. Okay, conflicting type. Right, we are ready to find that. Okay, not really str, but just call it S. I'm running out of okay. This got cons qualifier. Or maybe we can do something like this. A, B, maybe. Okay. Nope, we cannot do that. Okay. Maybe we can do something like this. B, C, G, Control E. Okay. Read only. Okay, right. So that is what happened. And for now, I mean, this is only a warning. So let's find out. AP, okay. Okay. Yeah, I'm not sure. I'm not sure if we need to change this to the constant type. Okay, well, I think something like this. And put in with this returning nothing. Okay. And well, maybe let's use this. Or maybe let me add explanation. We convert case file names to char. Because we have alpha put, not alpha, lenv put, which use which has parameter type for the symbol or variable we are trying to put into the environment. It might not be a constant value, I guess. Okay, but yeah, I'm kind of thinking maybe if we saving the variable, right? Maybe in this one, in this section, we need to, what is it called? Seems count. We need to treat a specific, what is it? A specific memory block or location, because during the REPL, right, we might delete the abstract syntax tree from the parser, especially after we print them out, right? Print the evaluation result. So yeah, there is that. Well, for now let's try out this section and see how it goes. Okay, can do that. How about the plus? Okay, this kind of weird, but well, me use my own example. Okay. Wait a minute. Tail. Okay, so we're evaluating this code expression, which means this one, right? And then we are evaluating this one head with the list here. So yeah, it returned 96. Nice. Okay, this one, the join one. Okay, this is the first quote expression, the second quote expression, and then we're evaluating the head here with return 42. Okay, return 42. All right. Symbol does not exist. Oh. Okay. Maybe we should. Alright. I'm already putting the release candidate tree in here. Okay. Should I commit this? Maybe I should. Wait. This is specific to GCC compiler. If we use another compiler, we might need to change this. Yeah, I'm kind of curious. Is this the macro to check whether we are using GCC or not? Say programming, check if the compiler GCC or not. Genus compiler collection. Okay. This is from the CLA1. Is installed correctly. Let me try Google. Okay, returning captcha. Check if the compiler is GCC or not. GNC means okay. Put and use variable. While 0 interesting. Let's read this first. The type compiler should be applied to question. For question, put the tile inner working of compiler. Option and setting for color compiler. Oh, this one. The tag, okay. To first have a look at documentation. In a time where documentation was a thing. It can serve as a default catch-all. It's common in compiler to define macros to determine what compiler they are. Version instead. That it can use a specific feature or not. And second one says the version number of MS compiler cipher. Whether OS is compiling my Python code using Gino. C++ keyword. Is it specific to C++? Let me check. Wait a minute. Okay. Can I use lectures? Not found, okay. If not lectures, okay. I think this one. So we have the specific version instead. Okay. 15.2. What? .2.0. .2.1. Okay. Let's use the default. Let's use the recent manual, I guess. No, not that one. GCC 15.2.0. Not found. Oh. Not found again, okay. Common. Gino. That is the C preprocessor. Okay. No, but never. To X minor to Y. Right. Patch level to Z. So to find if you invoke the preprocessor directly, if all you need to know is whether or not is being compiled by GCC or non-GCC compiler that claims to accept the genus C dialect, test genus C. If you need to write code with the pen, you must be careful. Okay, maybe we can try this out. Test.h. Oh, okay. Enjoy your late night snack, I guess, Richie. Yeah, I haven't had breakfast. Maybe I will get a breakfast after this. The fine. Okay. Before the include. C programming compiler error at compile time. Or warning in the C preprocessor. Where is it? This one, I guess. Okay, so we use error directive here. Error directive and must compiler to quote the message. Pragma. Let's do this. Yeah, I mean we are currently using the GCC or genus C, right? And then so we definitely will hit this one. That's why let's check this out. Need GCC to compile. Maybe something like this. Okay. Alright. Need GCC to compile. I forgot what is the pragma. Whoosh. So if pragma once fail, that method will still work. Let's this. Okay, we cannot really see that. The preprocessor to report a fatal error. Let me put this in the chat. Maybe this one. Maybe this one too. Declaring a depot function. Oh. Okay, it's kind of different. Common function like depot. And use. Maybe this one. Oh, not that one. GCC. Okay. So we run into error when we are trying to compile the library, I guess, or the source code using another. Let me put this in the chat. Okay, maybe putting this in the chat too. Document recommendation. As the error message, conditional data takes a combination of parameters. You have several configuration parameters. You can use conditional to detect an inconsistency and report with error. Okay. Neither error nor warning. Okay. Non-standard to be included only once in a single compilation. Include code but with several advantages. Automatic. Oh. They are not standardized. Okay. So pragma once, right? This one is a replacement for this. I think this is what is it called? The safety card that we only including the header once, and also there is an if at the end of the header. So if we already include this header file, we won't include that again during the pre-processing step. Okay. Alright. I think that's it for now. Thank you for watching and see you next time. Bye bye.